Hello friends, I am Rajnishar Chandran. Welcome back to this YouTube channel. Here we are discussing about engineering graphics, a projection of lines in engineering graphics. Through the last videos we have learned the introductory portion in trapezoidal method of projection of lines. Here we are discussing another example in the trapezoidal method. The problem you can see in your screen right now. The end R of a line RS is 25 mm below HP and 40 mm behind VP, and the another end S is 50 mm above HP and 75 mm behind VP. If the distance between the projectors of the lines is 50 mm, draw the projections, obtain the true inclinations of the respective planes and locate traces. The point R is 25 mm below HP and 40 mm behind VP, and S is 50 mm above HP and 75 mm again behind VP. If the distance between the projectors of R and S is 50 mm, draw the projections of the lines, locate the traces and also measure the true inclinations of the line. See, this is the problem. So we can start with the XY line. The XY line has been drawn. It is given that the point R is 25 below. So the point R dash is marked and it is given that 40 behind. So the point R is also marked. Similarly, the point S is 50 above. And the distance between the projectors of R and S is given as 50. So at a distance of 5 cm or 50 mm, we can draw the projector through S, and on that projector we can mark the point S is 50 above. The point S is 50 above means the point S is 50 above. So it will be S dash and it is 75 behind. So this will be 75 behind. Now we can complete the projections R dash S dash as well as RS. So I hope all of you have understood this much portion. Now just recap what we have learned in the previous question. See, if this is our XY line and if this was our projections A dash, B dash and AB, the method was take the distance between XY and A dash and draw a perpendicular from A dash. Take the distance between XY and A, draw a perpendicular having the same distance. Take the distance between XY and B and draw a perpendicular from B dash, so that this will be our true length. Similarly, take the distance between XY and A dash, draw a perpendicular from A. Take the distance between XY and B dash, draw a perpendicular from B, so that this will be our second or next true length. This was the method that we have learned through the previous problem. See, that is a method of trapezoidal rule, or that is a trapezoidal method, but there was a slight modification in this question, because see, take the distance between XY and R. Take the distance between XY and R and draw a perpendicular from R dash. So this will be our capital R1. Is it clear? Take the distance between XY and R and draw a perpendicular from R dash. Now take the distance between XY and S, because we have taken the distance between XY and R and draw from R dash. Similarly, we have to take the distance between XY and S. That means this much distance has to be taken. This much distance has to be taken. 70. And then we have to draw a perpendicular from S dash. S dash, right? So we have taken distance from XY to R and draw a perpendicular from R dash. Similarly, we have taken the distance between XY and S dash, this much distance, and draw perpendicular from S dash. Clear? So from this we have to mark this much distance. So that will be our S1, and this is our true length. I hope all of you have it. Now, take the distance between XY and R dash take the distance between xy and r dash and draw a perpendicular from r. So take the distance between xy and r dash and draw a perpendicular from r. So this is the perpendicular, and on the perpendicular we can mark this. So this will be our r2, provided this distance will be 3. So the next step is take the distance between xy and s dash. That means that this much distance, that is 4. But there is a problem. See, the problem is here the distance 3, that means the distance between xy and r dash was in the downward direction. Here the distance between xy and s dash is lying in upward direction or opposite to this direction. So if the distances that we are taking to draw the perpendicular are lying in the opposite directions, the rule is that line also should be drawn in the opposite direction. Simple. See, this is the distance of xy and r dash. Take that distance and mark a perpendicular from r. This is the distance from of s dash from the xy line, and the rule is we have to draw a perpendicular from s. But since this distance and this distance are lying in the opposite direction, we have to mark those distance from r and s also in the opposite direction. Since we have marked the distance 3 from r in this direction, we have to mark the distance 4 in the opposite direction. In the opposite direction. So we can, since there is a lack of space in the board, I am changing this direction, the direction 3 here. So take this direction, so that this will be our R2, and since 3 and 4 are lying in the opposite direction, from S we have to draw a perpendicular in this direction carrying this distance. So this will be our S2. So this is our second true length, R2. I hope all of you have understood. See, this is the distance between xy and r dash. Take that distance and draw a perpendicular from r. This is the distance between xy and s dash, and also we know that we have to take that distance and draw a perpendicular. But since these two distances are lying in the opposite direction, and since we have taken this distance 3 here in this direction, that should be in the opposite direction. If we have taken this direction, taken the distance 3 in this direction, this should have been taken in this direction. In any direction we can take, but the direction should be opposite, since the distances that we have measured is also lying opposite. So the distance between xy and r dash, take the distance between xy and r dash and draw a perpendicular from r. Take the distance between xy and s dash, draw a perpendicular from s. But since these two directions are lying in the opposite, directions, we have to draw the perpendicular also in the opposite directions. So this distance has been taken, mark here. This distance has been taken, mark in this manner. So that we have obtained S2 and R2 and complete or connect R2 and S2 for obtaining the true length. Now we have to measure the true inclinations theta, phi, and we have to look at the traces. We know that theta is the angle between the theta is the angle between the top view and the corresponding true length, right? So the top view is RS and the corresponding true length is R2S2. So this is the top view RS and this is the corresponding true length R2S2. We know that the angle theta is the intersection between the RS and R2S2. Since these two lines have already intersected, there is no need to extend both the lines to obtain the intersection. So this is the intersection point. This will be, or this will be, the angle between RS. So this will be the angle between RS and R2S2. So this will be our theta. We know that the horizontal trace is associated with the theta. So this will be our HT or HT dash. We know that HT dash will always lie in the xy line and HT will be above or below. So this will be our HT. We also know that R, S, HT and VT will always lie in the same line. can see that this is R, this is S, so this will be HT only. Draw a perpendicular projector that will intersect the XY line, so that this will be our HT dash. We can now see that R dash, HT dash and S dash are lying in the same plane. So theta and the horizontal trace has been obtained. Now what is phi? Phi is the angle between A dash, B dash, or the front view and the corresponding true length. Here the front view is R dash, S dash, and the true length is R1, S1. So we can extend this one and we can extend this, so that this will be intersected somewhere here. So that this angle will be our phi and this will be our vertical trace. This will be our vertical trace. So vertical trace means this will be our VT dash. Why? Because see, VT dash, R dash, ST dash and S dash are lying in the same line. If we extend this, clearly this will intersect the XY line here. So this will be our VT. So now we can see that VT, R, HT and S are lying in the same line. VT dash, R dash, HT dash and S dash are lying in the same line. So if we are getting these two conditions right, that shows what we have done in this question is correct. So I hope all of you have understood. The only difference between this answer and the previous one is here the distance of R dash, the distance between XY and R dash and the distance between XY and S dash are lying in the opposite directions. So we know that for marking the perpendicular, that should also be in the opposite direction. So we take this distance XY to R dash, mark here. We take this distance XY to S dash, mark in the opposite direction from us. That is the only difference between this problem and the previous one. In the next video, we can see another problem in the trapezoidal method. So I hope all of you have understood this question.